Welcome to this Roundup. Since technology helps us solve the complex challenges facing humanity and has become the most important driver for change, no nation or its industries can imagine survival, success, or sustainability without integrating technology to change the way they do things. Agriculture industry is no exception. From robots to drones and Internet of Things, technology seems to be fundamentally changing the agriculture industry. As technology tries to change the way we do things and solve the complex challenges facing the agriculture industry, it is important to understand and evaluate which technologies will drive the agriculture industry transformation. How will artificial intelligence-based robots revolutionize the agriculture industry and change the way farming is done and transform its value chain? And where will the technology transformation take nations? To discuss how technology can and will bring data and automation to traditional tasks of farming supply chain, making farming more productive and more profitable, using agriculture robots further, I am delighted to welcome Joseph Jones to this Roundup. Joe Jones is the co-founder and chief technology officer of Franklin Robotics and is based in the United States. His primary interest is the practical application of robotic technology to real-world problems. And in his previous roles, he has co-founded Harvest Automation, proposed and developed robots iRoomba, and served on the research staff at the MIT Artificial Intelligence Lab. He is a graduate of MIT and holds 60 plus patents. Welcome, Joe. We are honored to have you on Risk Roundup.
Thank you. It's great to be here.
Wonderful, Joe. So let's begin by discussing the broader challenges facing agriculture industry. It seems that the biggest challenge facing world agriculture is to produce enough food to feed the growing world population. So what role technology can play to meet the growing food demand?
Well, one of the things that made me interested in agriculture and the application of robots to agriculture was that I think that robots can help a lot. And the way that I got to that thought was by going to like a county fair. If you go to a county fair, you see these championship vegetables there, and there's these giant vegetables all around, and you don't see the same thing when you go to the supermarket. And I thought for a while, why is that? And I think the answer is because when a farmer or a hobbyist is trying to grow a big vegetable, you lavish attention on it. You're always thinking about what does that plant need and when does it need it, and keeping the bugs off and making sure that it gets the right amount of sun, the right amount of water, and keeping the weeds away from it. But you can't produce on a commercial scale if the farmer is, paying total attention to each and every plant on the farm. There's just not enough hours in the day. But a robot could do that. You could have a fleet of robots in your fields that would go out and make sure that they understood what what every plant needed, and give that plant exactly what it needs, exactly when it needs it. And by doing that, my vision is, anyway, that you'll see on the supermarket shelves exactly the same giant, perfect vegetables that you see at the county fair.
I think that's an excellent background on that, and you are right that there are so many different variables, and manually it is so difficult for anyone to be able to keep an eye on all that variables or to get the intelligence or the data in a timely manner to be able to take effective action. So that is where I think the automation, could play a tremendous role. And it is no secret that agriculture systems are complex. They are highly heterogeneous, fragile, and they are low in productivity, and they're dominated. If you look at, a lot of developing nations, they're dominated by small-scale farmers with very limited resources. The developed nations, the industries are quite mature, and there are a lot of, sufficient resources, I would say. But a lot of developing nations, they don't have that. So to increase the productivity of complex, low-yielding farming systems in ways that do not damage the natural resources, or the complex the environmental ecosystem is a very complex challenge. So do you think that the technology has reached a maturity, or we have sufficient technology that can solve the complex challenges facing agriculture industry?
Honestly, I don't think we can do it today. And the reason that the way that we can't is because you can't go out to a farm supply store and buy a robot that will take care of your plants. I think that we're getting there. It's really an exciting time to be working in robotics and working in agriculture, because I think during the next 10, 15, 20 years, we will solve a lot of those problems, and we will start to see robots growing food for us. But I do want to make it clear that I don't think we can't do that today. It's wonderful working on those problems, though.
Yes, absolutely. We are not there yet, but we are taking the positive step forward. And as you said, science and technology will have to play an increasingly important role in meeting the agriculture industry needs. While we don't have all the solutions at this point, we are taking, very informed and educated steps to go towards that. Now, based on what technological advances we have currently, where do you see the technology making a difference in the agriculture industry? Which technology seems promising to you?
Well, of course, I think the one that I'm working on is the one that's most promising. And the technology that I'm currently working on is my company has just done a Kickstarter for a little robot called Turtle that weeds your garden. I was really interested in that as a technology because on a garden scale, today I can use existing technology that will actually accomplish that job of weeding the garden. I don't yet know how to do that on an agricultural scale. That was where I started at my previous company, Harvest Automation. That company builds robots that move plants around nursery farms. But I was looking around for other potential applications, and I noticed that a lot of people are working on the problem of eliminating weeds from farmers' fields. And it would be great if you could do that with a robot, because instead of chemicals, because there's no sort of unintended consequences, or a robot, pull a weed out of the ground or smash a bug. There's nothing that's left over in the environment to cause problems. But when I was considering that on a large scale, I couldn't figure out anything better than what I saw other people already trying to do. And since I couldn't do that, it didn't seem reasonable for me to try to jump into that. But then I went to a robot conference, and an acquaintance there mentioned this problem of weeding in a garden as opposed to a farmer's field. And that made the problem tractable. And the reason that it's tractable is because the big problem in trying to do weeding in a farmer's field is having the robot identify what is a weed and what is a plant. And the usual solution is to apply some sort of a vision system, but that's really hard. The vision systems aren't quite up to the task, especially when you can't control the lighting and you can't control the background. So, but if you did it in a garden, you'd be able to cheat. And the way that you cheat is if you have a seedling and you want the robot not to rip it out of the ground, what you do is you put a little collar around the seedling, and the collar tells the robot that this is a plant you want and to leave it alone. So on a scale of a garden, you can do that. So I thought, I can start there. I can build a product that works today in a garden, and if the plants are big, then the robot will just turn away from them. If they're small, then it thinks that it's a weed, but I can correct for that by putting a collar around the plant, and I can do that today. Later on, the technology will mature, and either there will be a solution for the vision problem so that the robot can visually distinguish between plants and weeds, or the technology for marking the plants will get better, and I can use the technology, a similar technology to what I'm using now.
Yes.
That's how I got to where
That's excellent. I mean, you are right about it, that we would need to have more data. We would need to feed more data to these, intelligent robots. And that's where probably machine intelligence will come in and help, solve a lot of the problems that you are facing currently, to differentiate between, weed and the actual plants. And even if we, probably in the coming years, maybe we'll be able to, like you said, tag the plants that are actual plants by using IoT sensors. And that way these robots will be able to differentiate whether these are, the actual plants or weeds, and they will be able to do the job effectively. So from what I'm hearing, it seems that you are facing right now, one is the identification problem and another is the scalability problem.
Right. Exactly.
Are there any other problems that you are facing?
Those are the only things that I'm working on actively at the moment. I would love to get to other things. I would love to get to the point where the robot can harvest certain crops. Certain crops are easier to harvest than others. And that was another thing that I looked at while I was still working at Harvest Automation. There's a number of things that have to come together. So one of the things that I did was I was looking for crops that robots could harvest where it made sense. So I looked at all of the hand harvested crops in the United States, and I sort of applied a filter to them and tried to figure out, so of all of these plants, of all these crops, which have the characteristics that make it easy to build a robot to harvest that plant. And it turned out, surprisingly enough, it surprised me anyway, that the very best plant is asparagus. Now, the reason I didn't know that to begin with, but the reason that asparagus won that race is because the way that asparagus grows is a spear grows up from the ground, maybe several spears. Usually there's no foliage obscuring them from the vision of the robot, and it's easy to tell whether an asparagus spear is ripe or not. It just is how tall it is. So, and also it grows low to the ground rather than being up in a tree, so you have to build some difficult mechanism to get to it. So all of those things combined to make asparagus a really appealing crop to develop a robot to harvest. However, we did not develop a robot to harvest asparagus. And the reason was because when I did that study, there's only about $90 million worth of asparagus grown in the United States each year. The United States consumes a lot more than that. I think it was like $360 million worth or more is consumed each year, but only 90 million is grown. So there was no way that I could get any investors interested in developing a robot that would harvest asparagus when the return is so small. Now, I think the return actually would have been bigger because once you have a technology that makes it really inexpensive to harvest that crop, then some of the crop that may be grown outside the United States would move back inside the United States, and it would benefit farmers here. But those are the financial realities.
Yes, you're absolutely right. Those are the realities, and we are all trying to balance risk and reward. So who knows, maybe in the coming years, the reality may change. But other than the harvesting robots and the weed robots, what other robots are there currently for the agriculture industry where the industry can benefit in a positive way?
I don't know a whole lot that are actually on the job today. I know that a number of people are trying to develop robots. I know that there's at least one group and probably several groups trying to build a robot that will harvest or will pick strawberries. A group that's trying to work in a vineyard. There's at least one group that's trying to build a robot that goes down the row of a crop row and then sort of mechanically scrubs the weeds away. Beyond that, but I don't know that any of those are actually commercially successful at the moment. And I'm sure that there's lots of other things that are going on in research labs where people are trying to harvest other different crops.
Absolutely. I mean, at this point, I think you are probably giving us the data based on what we see in the United States, because what you told about the asparagus, that seems that, that challenge we faced in the United States. But what are the global market trends for the agriculture robots? What is happening in Europe? What is happening in Asia? What is happening in other parts of the world? Are they going aggressively towards, agricultural robots or automation of the industry?
Well, I'm afraid that steps a little bit outside my expertise. I'm a technologist. I look for problems that I can solve. I'm really interested in agriculture, but I haven't really made a careful study of what's available throughout the entire world.
No, I understand that. That's fair. But based on, you have a strong experience in the artificial intelligence and robotics. So how do you see robotics become the future of agriculture? and how will it modify the way we design the machinery? Because automation will require each and every aspect of the agriculture industry, not just harvesting or not just weeding, but also the machinery where tractors and other equipments that we use on the farms, they will need to be automated. Where do you see that going? Are we seeing some meaningful results there, or are we seeing some innovations coming out there?
Well, I can give you the technologist's approach to this. Whenever I think about designing a robot that will perform some task, I always think about redesigning that task from the ground up. And that means usually that I want to build one robot that has one purpose. It does one thing well. So I'm not anticipating necessarily that what we need to do is to design a robot that will be pulled by a tractor. So I want to think about the entire challenge of building a robot that will accomplish a task. And it may be that there are some that'll be pulled by a tractor, and the ones that interest me most are probably the ones that aren't done that way. But I can think of one more robotic application in agriculture that's successful today. There's this company called Blue River Technology in California, and they've developed an application that never even occurred to me, and the application is thinning lettuce. Apparently, when you plant lettuce, you have to plant a bunch of seeds because they don't germinate well. Either they don't germinate well, or they need to be beside each other to get a good start. But then after it's grown for a while, you can figure out which are the best plants. And really what you need to do is to go out into the field and remove about 90% of them, so that the heads of lettuce are spaced well and they have room to grow. And before Blue River came along, people would go out with a hoe, and it was laborious work. But now they have Blue River came up with this very clever system where they drag this box behind a set of boxes behind the tractor, and inside each box is a set of lights and a camera. They take a picture of the lettuce as it's sprouting, and then they have a piece of software called the jury, and the jury decides which lives and which sprouts live and which die. And when they want to kill the sprouts, what they actually do is they spray fertilizer directly on the leaves, and that turns out that kills the plants. And that's, I think, a very clever use of robotic technology in agriculture. And I think that there's going to have to be a lot of things like that, where you think very carefully about each particular application that you're interested in. Ultimately, we may get to a robot that will do all kinds of things at the same time, but I think that's a ways off.
Yeah, but you're right that at this moment there are bits and pieces that each and every robot is able to do. But in the coming years, who knows, we will have one robot do all of those things. But it will require integration of Internet of Things. It will require integration of drone technology. So a lot of integration challenges will also come into play. At this point, do you see the IoT sensors playing a significant role in farming and agriculture? Are you thinking of, is your vision about integration of IoTs with the weed sensors, weed robots that you have at the point?
We have thought about the IoT sensors for our application, and we have considered, even when I was working at Harvest, what information we could collect about a farmer's field that would actually be useful to the farmer. And it's kind of delicate. When people from drone companies talk, or people who want to sell sensors talk, they talk up how wonderful technology is. And I don't deny that it's wonderful, but at the end of the day, a farmer has to use that technology to make a decision. And there has to be a clear benefit to the decisions that are made. And historically, it hasn't helped that much. At least the anecdotal stories that I've heard is you identify that there's an infestation in a field, and you say, well, the infestation is right here, therefore you can just spray right here and it'll be fine. But what tends to happen, since the farmer literally is betting the farm, whenever a farmer discovers that there's an infestation, they spray the whole field. So it didn't help that you had this highly localized information. You just needed to know, is there a reason to spray the field or is there not? So the highly differentiated information that you can get from IoT sensors, I believe that it will come about eventually, that those will be very helpful, but it's a difficult road getting there.
Yes, I think so too. But I think it should be very, very useful because IoTs, these are low cost technologies, and the advanced analytics that we can get from that, we can get the data about the soil, seeds, livestock, all the crops, or cost or equipment, or how much water to use, what fertilizer to use, and what kind of data any farmer would need, like weather, temperature, moisture, communication signals. All of those things we will be able to get all that data. We'll be able to optimize and increase yield, and we can improve the farm planning. That is where I think IoTs will play a big role, and each farmer and basically the farming or agriculture industry, they'll be able to make smarter decisions about the level of resources needed and determine when and where to distribute those resources in order to prevent waste and increase yield. So I do see a very effective role IoTs could play, but maybe, as you just said, that we are still in the beginning stages and we still have to effectively put together all different variables or everything in the ecosystem that needs to be there to be able to move towards a smarter farming or smarter agriculture. But probably that will take few years or a decade, but we should be going there because there is a tremendous role IoTs could play. And in addition that, drones, I think they can be very effective in agriculture. Especially, you were just talking about the individual robot spraying the leaves, but if we want to spray the whole farm and do a lot more, I think the drones could be playing very effective role.
Yeah, I agree. I do think that the whole world of IoT offers a lot of information that will be very helpful to farmers, and ultimately I do believe that will be incorporated into farming decisions. But one thing that I have learned about building products is you have to sell them. And even if you can claim that your product is better, if it's only a little bit better, nobody's going to abandon the things that they're familiar with and know that those things work in order to take a chance on this thing that works a little bit better. So if the IoT world could demonstrate that using that information was like 3 to 10 times better than what farmers were doing now, then you'd have a revolution and everybody would switch immediately. If it's 10% better or 15% better, it's going to take a while.
Yes, you're right about that. It will take a while, and it all depends about what kind of benefits the farmers or the farming industry or the agriculture industry they are getting based on the, like you just said, they have to balance the risk and rewards. And if they see the meaningful benefit or advantage, then they will go towards that. The investments will pour in that, and there will be more and more innovations coming out because there will be enough money to be able to do research and to bring meaningful innovations to the market. So do you see that kind of demand from the industry to have more innovations, or they are happy with the labor that they have, currently cheap labor across many nations? So they are not too keen to automate or use the amazing advantages that come with machine intelligence, artificial intelligence, and drones and IoTs.
Well, farmers are willing to adopt new technology, and that was one of the conclusions that we reached when we were planning harvest automation and thinking about what we were going to do. But farmers are skeptical, and they want to see the things actually work and work better before they will adopt the new technology. And most of them are not early adopters. Most of them want to see that, well, if my friend down the road, my neighbor up the road have this technology, then I'll get it too. So that's why it takes a while for such things, if they're not a breakthrough technology. Now, sometimes there is a breakthrough technology, like, for example, in the olden days, and I don't remember which year it was, but for a long time, all tractors had steel tires. They didn't have rubber tires at all. They just had these steel paddles. And then a tire that would work on the farm was invented, and within 10 years, every tractor had rubber tires. On the other hand, the tractor itself took many years to be adopted fully on farms, and because apparently it was better, but not better enough to get over that hump and make everybody have to have it. So technology, I love technology. I've spent my career in technology, but it has to be applied in the right way, and you have to sell people. It has to be good enough to get people's interest.
Of course. Now that goes without saying, but at the same time, the kind of challenges that are coming our way, coming towards nations, are really very serious challenges. For example, the world population is growing so rapidly. We would need to grow enough food to feed all that growing population. And at this point, based on what my research says and what data I have been able to collect, is that about 90% of the food that is produced within any nation, it goes towards feeding that population of that particular nation. So there is not enough left to ship it to other countries to be able to meet their needs. So as in the next 10 years, our world population is going to grow so rapidly. So to be able to manage the growing market need for the more food, we would need to automate. We would need to use all kinds of smart intelligence that comes our way. Especially, like, another big variable I consider is that other than the growing need of the food, the other is that the diminishing water resources, the fresh water. We don't have enough quantity of fresh water, and in the coming decades we are going to have scarcity of fresh water. So how to use the water effectively, that is also another very important driver of this. We will be able to develop, come up with smarter ways to make sure that the plants do need water resources to grow, but how to effectively provide them. Do we want to spray the whole field with water, or do we want to just go individually towards that plant roots and we make sure that we provide the water only there? And there are a lot of different variables come here. So I think these are just two examples. As we go forward, there are many complex challenges coming our way, and for any nation to be able to meet the agriculture need of their population is going to be the very complex challenge in the probably 1 or 2 decades, in next couple of decades. So we will have to, at this point, we don't see that much strong interest or desire from the farmers or the farming industry or agriculture industry, but that would change, very soon. The market dynamics are changing, so it's going to change very quickly. So let's talk about the United States. Which, other than your organization, Franklin Robotics, and I think you mentioned another organization that you were involved with previously, which other are the important players in the agriculture robot market?
Well, let's see. I don't know a lot of other robot companies that have products in the market today. I know that there's a lot of research. I know that, well, not in the United States, but a company called Bosch in Germany is doing a lot of work in robotics, and they have this robot called the Bonnie Rob. It's a very clever robot. It has 4 sort of outboard wheels that can turn independently, and the whole platform can move up and down, and you can put different modules on the robot to do different things. So as a research platform, it's great. As a practical product, I worry about it because it's really expensive. I think someone told me that there's like $250,000 for each one, and they were thrilled that they had sold like 5 or 6 of them. But to make a difference, you need to sell lots and lots and lots of robots. So my approach is to look for applications that can be done at a much lower price. It doesn't help to have a robot that is so good that nobody can buy it, that nobody can ever use it, right? So you really have to look for the low-cost applications. So certainly my organization is working on low-cost applications, and I would encourage others to do the same.
Yes, absolutely. And you are right that it has to be cost effective. The farmers should be able to afford it. It has to be accessible, affordable, and effective. So those are the three fundamental, factors that we need to consider when we develop any new technology. Like you said, if we have a perfect technology but so expensive, nobody can afford it, it doesn't make sense. We don't want to put the technology in museum. We want to be able to use it. So you are right on that. And if you, I mean, based on what challenges or you are going through as you try to develop new innovations, as you try to develop more new technology to be able to help the agriculture industry, what are the, you mentioned about the in the beginning about the uh, scalability and some of the challenges that you were facing, while you were developing this robot at Frankly Robotics. But what other challenge, non-technology challenges or policy challenges or regulatory challenges you are facing that where you would like to see things change? So what is it that you would like to change in how nations address the agricultural robots or the industry, and what kind of support you would like to have?
Well, it's always more research support is always a good thing. There are accelerators and there are groups that help people bring ideas to market, and I think all of those things can be very helpful. But from my point of view, the bottom line is the problems that we are addressing are really just very difficult, and I can't think of any government policy or any other thing that would just solve them quickly. It just takes a lot of people working on from a lot of different points of view, a lot of people working for a long time, and I think that we'll come up with the answers. I don't feel like in the case of my own company, either Franklin Robotics or Harvest Automation, I don't feel like anything impeded us. There were no cumbersome government regulations or anything that slowed us down or stopped us from doing something that we had wanted to do. It's just solving those really very difficult problems and solving them in a way that, I mean, it's not too hard to solve a problem in a laboratory. There's all sorts of wonderful demonstrations of robots doing very clever things, and you can make a nice news story about it. But to build a robot that works out in the real world every single day and almost never fails, is rugged and is inexpensive, that's tough. And it's just going to take a while and a lot of people thinking about it to make that work.
You are right about it. It is tough, and a lot of people need to think about it. And for that very reason, there are so many young minds, students all across, nations, universities, and who are not, in the academic world, and who are just full of ideas and desire and passion to solve the problems that are facing not only their industry but their nation or other nations. There are so many young minds who are really, really keen to solve the problems to make the world a better place. What would you like to tell them?
Keep at it. When I started in robotics, which was over 30 years ago, the only people who could participate in robotics, building robots, were a few research institutions around the world. This was a time when to buy a video camera was like $50,000. Today, it's so much easier. There's microprocessors, there's all kinds of really inexpensive kits and really inexpensive sensors that you can get. There's all sorts of different building systems, Lego and Vex and a bunch of others. It's so easy, so much easier to get started now than it was 30 years ago, that I would just encourage everybody to jump into that. And also robots are used in education in ways that they were never used before. It's the explosion of interest. I think is just amazing, and I love it. So I hope that anybody who has an idea, any young mind who wants to apply themselves to an idea, you can now at a very low cost. You can get a few sensors, you can get some electronics, you can program it in an open source system, and you can build something. So I would encourage people to do that.
Yes, absolutely. And you are right about it that now things are so accessible and affordable. I mean, talk about the nano satellites. The one challenge for any farming or agriculture industry to get data in a timely manner so far, because of the large satellites, and we were not getting data that frequently. But now with the rise in nano satellites, we should be able to get data pretty much every 10 minutes or 15 minutes if we so desire. We just have to put the nano satellites in certain positions and to make sure that we get all the data. And it is so economical to have our own nano satellites in space now. So the technology has advanced so amazingly and so rapidly now that IoTs and nano satellites and machine intelligence, artificial intelligence and drones, if we collectively use all the technology, any problem can be solved. So thank you, Joe, for participating in Risk Roundup today. We appreciate your thoughtful insight on agri-robots, robotics, drones, intelligent machines, and technology that is transforming the agriculture sector. Our global viewers and listeners would benefit tremendously from the understanding you provided on the impact robotics, artificial intelligence, machine intelligence can have on the agriculture industry today and in the coming tomorrow. So even if a single individual student or any other individual or any entity across any industry or any nation can come up with an idea to innovate based on the understanding they receive from the discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Thank you. It's been my pleasure. Thank you very much.
So while the ability to create autonomous intelligent robot with perception, cognition, and action that could manage the complex challenges facing agriculture industry is very real and near, it is important to evaluate the complex risk that comes with the automation. Risk group cybersecurity, geosecurity, and space security risk research centers are created for this very reason, to identify, evaluate, and manage the risk facing NGIOA in CGS, that means nations, its government, industries, organizations, and academia in cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace, they walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. It is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the Risk Roundups, to watch the Risk Roundup videos or hear the Risk Roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayashree Pandya, host of Risk Roundup, signing off. See you next time. Thank you.